Okay, let's keep going. So in the research, they have to do the research design and the best to test their hypothesis. And there are different kind of research method. Sometimes use observational study, especially in development. They do a lot of observational study. It could be an unnatural environment. You can in UT they have the psychology department. They have the children development lab. It's actually a room. It's set up a room so all the tables were organized exactly the same way, and they just put the camera and watch the behavior. It can be a nature or unnatural environment. It can be a nature environment like the Jane Goodall. Yeah, she spent more times in her life with chimpanzee than with human. She just watch their behavior. So it can be a nature, can be unnatural, observing in the nature surrounding or unnatural surrounding. And in developmental psychology, we're going to spend a lot of time talk about this experiment. Like we're going to talk about Piaget. You are familiar with it in the intro psych, but we're going to talk about it again in a more biological approach. It's good for, so every methodology have their pros and cons. Observational study, very good for infant children, especially they don't have good verbal skill. You can just watch their behavior. This is one observational study. I'll provide a link to you. This show you those toddler. They don't have verbal skill yet, but they have the nature. It try to show you that the human will naturally want to help other people. We're social animal. So even though those toddler, they found like this gentleman, he tried to open the door. He pretend he could not open the door, and even though they don't have language skill, they will go to help. It's a pretty fun video to watch. So it shows you the human can watch other people's behavior, and we are social animal and help them. We always want to help other people. And in the last of the video, it actually shows you the chimpanzee. They found the young chimpanzee have similar behavior. They work as a team to help each other. So the young chimp and human in the development, the first 3 years, we are very similar with the chimp. And the chimpanzee and human, we have 99% DNA identical, not just similar, identical. And after age 3, the human development keep growing up, and the chimp's development are limited. And one big reason is the language. Humans have a very complicated vocal cord. We can create a language. It limits the development of the chimp's behavior. I'll leave this video to you. Another methodology called the case study. And case study is we study one individual or very small group, like 2 or 3 case study. They always have the advantage, disadvantage. Advantage is you can go deep. You can go very deep. Provide a lot of information. But limitation is more difficult to generalize it to the whole population, because usually we study special case. Like this Nandy Suleiman. Do you know her? She has 8 kids. She has 8 kids. So due to the she go to the clinics, received 8 embryos. She has 8 kids. She's controversial. The reason is she's a single mom and she does not have good financial support of her kids. So she depends on other people to help her, but she decided to have 8 kids. And if you are interested, you can watch those YouTube talk about her. That's her case. So that's the case study. And another one called survey. Survey is usually in human. You give them a questionnaire and ask them a lot of questions. You can give them 100 questions, ask them how tall they are, how much they weigh, their socio-economical status, what's their education, what's the degree they have, how much money they make, and then correlate it with anything you can find. And that's correlational study. And in the correlational study, you find one factor, how it's related to another one. It's correlational study. So you can correlate their height with their income. Actually, we do find in psychology, they do find people are taller actually have higher income. That's what they found. And they find the correlation coefficient, give you a number, right? And last time in chapter 1, I explained this. It's very important. So the correlation coefficient give you a number between +1 to -1. No matter it's plus or minus, if this number closer to 1, highly significant. You can have a positive correlation, highly significant. You can have a negative correlation, highly significant. If the number close to 0, and means no correlation. So that's correlational study. So it gives you a number between -1 to +1. The correlation can be positive, correlation can be negative. And the number is closer to 1, absolute value closer to 1 is more significant. And the absolute value close to 0, non-significant. Like this study from your textbook. So you study the correlation, the first test score. So every time, I tell you, every time you have a table, you look at what's in the X, what's in the Y. So the X is the first test score, and the Y is the final exam score. And they find, oh, okay, well, positively correlated. You can kind of draw a line here. So the student usually test pretty well in the first test. They tend to test pretty well in all the exam and the final exam. And if they tend to test badly in the first one, they tend to test badly in the final. So it's a positive correlated. And you can have a negative correlation. This one is number of absence with the exam score. So when you look at this, you found, oh, okay, this is negative correlated. The more you miss the class, well, the less score you have, this negative correlation. Or you can find nothing. Like the social security number with exam score is not correlated. So this is correlation close to 0. And in the correlation study is very powerful, especially in human. It's sometimes difficult to do the experiment and do the correlational study. But when you explain the correlational study, you need to be careful because correlation is not causation. It's not causation. So you cannot use the causation conclusion to talk about correlational study. Like in previous chapter, we talk a lot of it. A lot of study of drinking coffee and relationship with Alzheimer's disease, or drinking wine and its relationship to the cardiovascular disease. And sometimes you find the title, they use the causation, like they prevent Alzheimer's disease, prevent heart attack. And you know that's wrong because it's not a causation. It's only a correlation. And sometimes correlation can make a mistake. If you study the correlation, depression and impaired sleep, we find these two are highly correlated. We will talk about depression in the last chapter of normal psychology. And one symptom is sleep deprived. You can say because they're depressed, it causes sleep deprived. It makes sense. Well, you have too many things going on in your mind, you cannot sleep well. Or it's because of sleep deprived cause depression. It can happen. In animal studies, if the animal are sleep deprived, eventually they cause some psychological disease. So this can cause this as well. Or it can be caused by something else, right? It could be some family conflicts. It causes depression, causes impaired sleep as well. So it's caused by something else. And that's why you need to be careful when you explain the correlational study data. We talk about this. We find a correlation between the ice cream sales and burglary rate. These two are correlated. That's true. But it's not a causation. It's not this causes this or this causes this. And the reason is weather. It's the weather caused. So in the summer, more ice cream sales. In the summer, more burglary rate. So this happens in correlational study. So correlation is not causation. If you really want to do the causation study or have a causation conclusion, you have to do the experiment. And we talk about this. this experiment. You want to study the kids. They don't spend enough time with the mom during development, and when they grow adult, they're going to have a higher chance of psychological disease, and that's the experiment. You have to manipulate some factors in the environment, and turn out that something you manipulated is called independent variable, and the results you measured is the dependent variable. And in the experiment, you're going to divide those sample into different groups. So you have the experimental group, you have the control group, and you need to be careful, you have the random assignment. You cannot put those big, strong pups into one group and those weak, sick one into another group. You're going to find some difference in those. So you need to have the random assignment. Okay, let's take a short break.